Hello everyone, welcome to Big Data Thoughts. This is Shreya Pal, and today we are going to talk about some very important fundamental concepts in Spark which will help you to go for interviews, to write your own programs, do performance optimization. Basically, these are core concepts which have to be known by someone who wants to work in Spark. So, let's get started. First of all, let's talk about a very basic thing and something that really contributes to the performance that Spark offers. So, as we all know, in Spark, whenever we write a program, there will be a DAG or a directed acyclic graph created by Spark to execute that program. That's Spark way of execution. But how does Spark or when does Spark create a directed acyclic graph? Only when Spark encounters a action, which means in any Spark program there are two types of things that we write. One is transformation, the other is action. To perform any logic, we will write a set of instructions to Spark which constitutes of transformation and action. Transformation is something like a map, a filter, which is lazily evaluated. The whole lazy evaluation concept is there because Spark does not create a DAG when it encounters a transformation. Only when it encounters an action, something to be actually done, for example, doing a count, doing a collect, only then will it create a DAG and start the execution. Which means this is a very optimized execution plan. Why? Because it will reduce our shuffles, intermediate data storage, because we are until we encounter an action, Spark is just going on reading all the transformations and then it decides how can it club or combine those transformations so that it can reduce the number of stages. It can reduce any data shuffling. Since we all know Spark works on a distributed cluster, it's a distributed architecture, so any kind of data shuffle is expensive, and our goal in performance optimization is reduce any kind of wide dependencies. Wide dependencies means wherever data needs to get shuffled across the network, we want to reduce that, and that's where lazy evaluation helps, because it will create a DAG or execution plan only at an action. So it has the freedom to look at all transformations and combine them as applicable, right? So that's lazy evaluation and one of the fundamental concepts in Spark which helps in performance optimization. Then another thing which will really help in improving our performance is data partitioning. What is data partitioning? Simply, as the name suggests, splitting the data into partitions so that it can be parallelly processed across the distributed network. The whole beauty of a distributed architecture is parallel processing. How would we do that? We have written a program, but the data that we have is huge. It's a big data world that we are talking about, right? Now that data is chunked into multiple partitions and it can be parallelly processed. That's how we'll achieve performance. Now there can be ways of partitioning. One is custom partitioning, where I will call a partition by method on my data frame, and I will try to partition my data, and I will try to see if I can co-locate the data that is a related data. Can I co-locate that? So that the whole aim is to reduce shuffles. That's a custom partitioning that I can decide by what key do I want to partition. There are some inbuilt partitioning functions given by Spark. For example, repartition or coalesce. What is repartitioning? Repartitioning, it is also creating partitions, but these are the two ways that Spark provides. Now the difference, and this is often asked, there is a video I have done separately to explain in detail all of both of these concepts. I'll put that link also here. But essentially, repartitioning is there is a data that you have, you want to repartition that. So one function is repartition. Now what it does, the benefit of repartition is that it allows you to increase or decrease the existing partitions that your data has. But of course it is expensive, because when you are changing the number of partition, you are shuffling the data across the entire network. Coalesce is less expensive because it only allows you to reduce the partitions. So it is not doing a widespread entire cluster across shuffle. But data partitioning is very useful to have related data at one place for your job execution, and also when you want to get some performance benefits. So custom partitioning is one, other is the inbuilt repartition or coalesce. Then coming to catalyst optimizer. What is a catalyst optimizer? And all of these that I'm talking about, fundamental concepts, are actually related to the performance in Spark. What is a catalyst optimizer? So Spark has a query optimization engine which will create your execution plans. Right now there is a optimizer inbuilt in Spark which is catalyst optimizer. So with version upgrades in Spark, they have come up with new features, right? So every time a Spark version is launched and there are some, let's say, issues observed, or in the next version those issues are fixed, or there are new features coming up for enhancement, performance improvement. So catalyst optimizer is one of the performance improvement features. What it does, it is helping to create a optimized query execution plan. Now so few of the things, right, that we can do is that we push filters to the data source using filter early in the transformation. Why should we do filters? So whenever we write the code and when the query execution plan is getting written, what Spark execution engine or catalyst optimizer will try to do is push the filters upwards, because if you filter the data first and then do the other operations, it is more optimized. Reason being, the data is reduced, so your shuffle across the network will be lesser, or the volume of data shuffled across will be lesser. Okay. So that's one. The second performance optimization is we should use built-in functions instead of UDFs. It is more performance efficient when we write our do not write our own user defined functions, but use Spark given functions, because those are optimized for execution. Okay. Other thing that we do is broadcast variables. What are broadcast variables? Efficient distribution of large data which is read only to all the worker nodes. We don't want to do, while executing a job, we don't want shuffles to happen, right? So for that, what can we do? We can push anything like a lookup table or small data set, or it is some large. When I say large, it cannot be a huge data, a data which we don't want to shuffle across while we are doing the job execution to every node, because we know that this is like a lookup or something that the during execution every node will need. Then we want to make it as a broadcast variable, so that by using the function broadcast, right, now what will happen is this will ensure that this data is present on each of the executor nodes and there is no shuffle across the network. So this is a very useful method, but we should use it with a caution. It cannot be a very large data set, because it will cause a memory overhead. You will have this data set stored in memory of each executor. So if it is too huge, it will become a problem. Then let's look at some things which are very useful for doing tunings and optimization in Spark. Okay. The first thing to look at is memory optimization or memory management. What is memory management? The memory that, here we are specifically talking about executor memory. Now executor memory, we have two properties. One is Spark executor memory and Spark executor memory overhead. We can specify these properties. Every executor will need some memory for its execution, right? And in that memory also there are two broad categories. One is used for storage and one part is used for actual execution. Storage is nothing but a data that we are caching, something like a broadcast variable or any data that we are caching. Execution memory is whatever the executor is using for shuffles, joins, aggregations. So it is important to set up the properties of executor memory overhead very carefully. And also we can set up the memory fraction property, which means how much should be the storage memory versus the execution memory. That ratio we can adjust using Spark memory fraction. Now if I know that I will need heavy memory for my execution, I can increase the ratio for execution memory. Vice versa, if I know that I will need a lot more storage than processing memory, I will titrate on that fraction ratio. So these are some levers that Spark provides to us for doing efficient memory management. Then another important thing is shuffling optimization. What is shuffling optimization? So first of all, as I have been saying this, that one of the most important thing to keep in mind is to avoid shuffles across the network. That is very expensive operation. So we cannot avoid shuffles absolutely. There will be shuffles, but we want to minimize it. So how do we reduce shuffles? There are certain things we can do. For example, we can use a reduce by key instead of group by key. When you use a group by key, you have to bring in data from multiple nodes at one place to do a group by. Instead of that, we can use a reduce by key. We can use map partitions for transformations that can process multiple rows per partition. So the map partition will help you to process a bunch of rows together. So these are some of the ways to reduce shuffles. Other ways to reduce shuffle is doing a sort merge join instead of broadcast join. Broadcast joins are good only when one of the data set is small, the other is big. So you can actually do a broadcast join. Otherwise, what should be preferred is a sort merge join. And there is a property in Spark which is Spark SQL auto broadcast join threshold. This property needs to be set for us because when Spark tries to do auto broadcast join or a broadcast join, this threshold will ensure whether there should be a broadcast join done or not. So we can use this property to control whether we want a broadcast join to happen, and in what case we will not want it to happen is when both the data sets are really large. For broadcast join, one data set has to be small to be broadcasted to every executor, and the other one can be larger. So these are some things to keep in mind to optimize shuffle. Then comes caching and persistence. Now this is important. If we can cache data, it will help us to get performance benefits. So we can use the cache function to store intermediate results in memory so that we don't have to recalculate them. They can be used repeatedly. And you can use different persistent levels for caching. It can be a memory only, which is fastest because your data is in memory. No recomputation is required. But you can have a memory and disk also. In that way, there is a fallback option. If the memory gets full, the operation will not fail. In the first case, it will fail because if the memory is not sufficient and you have set memory only, it is fastest, but it can fail. One other option can be memory and disk. So it uses memory first. If it becomes full, then it falls back to the disk. So these are the two ways in which you can use caching to increase the performance. Okay, so we spoke about some of the concepts, advanced concepts in Spark. We spoke about how to do tuning and optimization. Now we will talk about debugging and monitoring. This is also a very, very important aspect because if we can effectively, efficiently debug and monitor our programs, then we can make them more performance efficient. So one of the easiest way, and this is known to every Spark developer, one of the easiest way to look at your program, debug, monitor, understand what stages, tasks are going on is to access the Spark UI, which is by default the master node IP working at 40 port. For local jobs, again, it will be master IP, the IP of the master and 8080. Okay, that's how you access the Spark UI, and there will be specific tabs for jobs, stage, storage. So you can look at what are the running jobs, in progress, completed jobs, the status, and it gives you a number of other details. Plus there is a tab for stages, which is a detailed breakdown of task and execution. So one job can have multiple stages, each stage can have multiple tasks, and those tasks are getting executed on the executor, which is ultimately using some memory. So all of this information top down can be looked at in the Spark UI. Okay, that is one of the easiest way to debug and monitor. The second way is looking at the logs. If you want to look at the detailed information, the best way after Spark UI is to go to the logs, the driver logs, the executor logs. In Spark you would have a driver and multiple executors. Executors are where actually the task is getting executed. So we can look at both the logs to understand the reasons of failure, whether it is a memory failure, what kind of failure it is, right? Then comes metrics and instrumentation. Now this is something which is over and above what Spark provides in terms of logs and UI. So we can integrate with our own third-party monitoring tools like Prometheus, Ganglia. There are plenty of them. But usually in any real-world scenario, people do have some debugging monitoring tools associated with our setup. We can use custom logging, which we always do, right? In our programs we do a lot of logging to understand what is going on in the particular logic that we have written. So this is all in addition to what Spark provides. So there are n number of tools we can use. People use Grafana, people use many other tools to monitor what is going on in your application, but specifically for Spark you can use the logs in the UI. Now this was all about, in a very crisp manner, all the concepts and everything. I hope you liked the video. Please like, share and subscribe for more interesting videos on big data and cloud. Thank you so much for watching.